or in 6th grade. In an attempt to try to make these videos just a little bit shorter, what I'd like you to start to do is take your quiz, take your power up, be all set with that by the time you log into your video, so your video can just be right to the lesson, and I won't spend time anymore telling you to take the quiz and do those things. So what I want to start with today is I'm going to work the problem solving with you. I know they have this one shown for you again on the work, but I like the thinking because it's just a great practice for us to be able to understand. We're missing numbers in subtraction, so I'm going to look at this the backwards way. I'm missing the second number in subtraction, so I still subtract. So I got 0 minus 3. Now some of us are going to be tempted to say it backwards, 3 minus 0, and write in a number 3 here. No, this is 0 minus something equals 3. And so I need to switch this from a 0 to a 10. Still subtract, 10 minus 3 is 7, so this gets the 7 here. Now I'm going missing the first one I add. 1 plus nothing is 1, but I need to remember it's not 1 because I crossed it out and borrowed 1 over, so it's 1 plus 1 is 2. I had taken the 2, crossed it out, and made it a 1. That's how I got the 10. Then 1 minus 0 is 1. This one is 7 minus 6. Can't do it. 7 becomes a 6. This becomes 15. 15 minus 6 is 9. 6 minus, I don't know, missing a second. I still subtract. 6 minus 4 is 2. And that's how I fill in the blank for problem solving. Good. Cruising on to lesson 5 today. We'll start with a quick review from yesterday with number lines and sequences. Remember, number lines, we have negative numbers now. When we add negative whole numbers, those are called integers. Keep our vocabulary straight with those things. If the subtraction problem is ever set up backwards in our mind, the smaller numbers first, remember the answer is going to be negative. Then there's two types of sequences. Equally spaced one is arithmetic. We're either adding or subtracting the same number. And then geometric is multiplying or dividing by a number. The last reminder, do not forget perfect squares. 1, 4, 9, 16, 25. Taking the individual numbers and squaring it. Today, guys, you have your yellow folder. We're cruising through lesson 5. It reads like this. In our number system, the value of a digit depends on its position within a number. The value of each position is its place value. The chart below shows the place value from the ones place to the 100 trillions place. Guys, that chart that I photocopied it into your notes for you is a great resource if you can't automatically know your number system. If you were sitting in the classroom, you can see behind me on the wall I have it in both directions from the trillions to the trillionths when we start to get into the decimal system, and we use that wall all the time as a resource. Because you're not sitting in the classroom, I would use that chart that you have photocopied there. As you're filling in your notes, place value, the value of a number based on its position. When we go through ancient history, you're going to see a lot of ancient civilizations that will talk about, hey, they had place value. That was an invention that they created. We take it for granted today, but it's obviously very, very important. We're ready to work a few examples already. So example number 1 says, which digits is in the trillions place in the number? Now you got some options, guys. You can look at your chart that's in your book and say trillions is there. It's 1, 2, 3, 4, 5, 6, 7, 8, and count the numbers there and then turn around and count. What we want to get to is these are your units, thousands, millions, billions, boom. Trillions would be the first one, so the answer to A is that number 2. B says, in that big, huge, long number, what is the place value of the 4? Units, thousands, millions, billions, billions, 10 billions, 100 billions. So it's always place, tens, hundreds. Place, tens, hundreds. This is in the billions place, 10. It's in the 100 billions place. And you could have wrote that down for your answer. What is the value of it? It's the 100 billions. Okay. In between that it says this. We write a number in expanded notation by writing each non-zero digit times its place value. For example, to write 5,280 in expanded way, we write 5. What place is it in? It's in the thousands. So 5 times 1,000 in parentheses. Plus 2, what place is it in? 100. We're at 100 plus 8 times 10, and then we're done because 0 is we don't need to mess with 0. So that's why I said non-zeros. So then they asked us to do it down here. You got two choices in my mind when I'm looking at 25,000. The first one is say 2. What place is it in? It's in the 10,000s place. Put that in parentheses. Your other choice, guys, if you're not good, is count how many numbers are after it. 2, then there's 4 numbers. I need 4 zeros. Plus, next number, 5, how many zeros are after there? 3 zeros, put 3 zeros. Or say, what position is the 5 in? It's in the thousands, so I write the number 1,000. Don't have to do anything else because the rest of those are zeros, so I don't need it in expand notation. It's 2 times 10,000 plus 5 times 1,000. Turning the page, we're going to learn how to read and write them. Whole numbers with more than 3 digits may be written with commas to make the numbers easier to read. Commas help us read large numbers by separating trillions, billions, millions, and the thousands place. We need only to read the 3-digit number in front of each of the comma and then say the place value, trillion, billion, million, or thousand, when we reach each comma. We will use the following guidelines when we are writing numbers as words. Number 1, put commas after the word trillion, billion, million, and thousand. Number 2, you hyphenate every number between 20 and 100 that does not end in 0. For example, 52, 76, 95 was written as 50-2, 70-6, and 90-5. So they're just teaching us how to write things. What they're saying, if it ends in 0, it doesn't get a hyphen. So 20, 30, 40, 50, those numbers don't get hyphens. All right, my job is to write this big, huge, long number that I have up here. So the first thing I'm going to do is figure out the place value. So units, thousands, millions, billions, trillions, and then I'm working in groups of 3. What do I have? I have 1 trillion. Then they said make sure you put a comma. Done with that one. Then I look at the next 3 numbers, and I spell that out. That is 300, 80, and it's in the billions position. Put a comma. Done with that one. There are no millions, so I cross it out. The next group of 3 is the number 50, so I write 50. It's in what position? The thousands, so I have 50,000. The last group is 200, and I simply write 200. Notice I never use the word and. We gotta remember that 6th grade. When you listen to people, they talk wrong all the time when they speak math. They'll go 1 trillion and 380 billion and 50,000 and 200. Don't say and. And in math means decimal. And so there's no decimal here, so don't put it in there. Example 4 says, I'm going to make it one step harder. I want you to write in words again, but this time I just gave you a bunch of numbers. Step 1, go and add your commas, right to left. 1, 2, 3, 1, 2, 3. Then in words, that's 3 million, comma, 406. Some people are tempted to say 406. Nope, 406, and it's in the thousands position. Comma. Last number is 500, 21, and I need that hyphen that we just talked about, 521. Number 5, it says use digits to write this. So we just did 3 and 4. We gave you the numbers. You have to write the words. Now we're going to give you the words. You have to write the numbers. So the first number is 20, and I write it. Comma. Now I got to get that to the trillion. So I put a comma there. Then the next thing is 510 million. So there were no billions. So I have 20 trillion. There's no billions. So I put 3 zeros there. Then I have 510 million. Put a comma there. There are no thousands. 3 zeros. There are no units. 3 more zeros. So 20 trillion, 510 million. Make sure you have those groups of zeros or you would have gotten it wrong. So that's the power of place value. Middle of page 37, there's 2 more lines. It says large numbers that end with many zeros are often named using a combinations of digits and words, such as 3 billion. Because I don't want to take the time to write 9 zeros out there. It's actually faster lots of times to just write the word that is there. So now number 6 says use only digits and commas to write 25 million. So I write 25, And we want to get in the habit of saying million has 6 zeros in it. So 1, 2, 3, comma, 1, 2, 3. Billion, 9 zeros, trillion, 12 zeros as we work those things. Last but not least is example 7. Terrell said he and his family traveled 2,400 miles on a summer driving trip. Use digits to write the number of miles they traveled. 100 has how many zeros? 2. So I write 2,400. Many of us will say that's 2,400. Lots of times we'll use 100 and say 2,400. You kind of got an example of that in your power up today, your mental math. If you were doing letter C, it said write 10 hundredths. We're like, what is 10 hundredths? What do you mean? It's 10. How many zeros are in 100? 2. You're going to say, Mr. Brown, we call that 1,000. Yes, we do. What's 1,000? It's 10 hundredths. So there's a different way to write that, and they're just teaching you to practice that. With 4 digits, guys, the comma is your choice. So some of you put commas there because you're taught, hey, after every 3 numbers I need a comma. The 1,000's the exception. You can or cannot. It doesn't matter either way. Okay, you got some practice set. If you want to practice, guys, the skill of reading and writing these big, huge numbers is going to be really important. Make sure you have that base. We'll see you for the written practice in a second. All right, 6, welcome to another set of doing math problems. Hopefully you have your answer key for number 5. We're ready to rock with number 1. Number 1 says, what is the sum of 607 and 2,393? Okay, so from today's lesson, the biggest skill is being able to write these numbers. So I say 607, and then the next number is 2,393. I'm going to write on top. I like the bigger number on top for addition. It doesn't have to be, guys. It's your choice. So 2,393. So this is the biggest key here is can we take words and put them into numbers? They asked me for the sum, which means I add those together. 3 and 7 is 10, carry the 1. 1 and 9 is 10, carry the 1. 1, 3, and 6 is another 10, carry the 1. 1 and 2 is 3. So when it's all said and done, I get an answer of 3,000. Number 3, use words to write this big, huge number. So the first thing I see is it's the number 50. Then I got to figure out what position it is, and I count it over. I start at the right. That's in the units, then the thousands, so that's 50 million. Then I need that comma. Then I look at the next 3 numbers. That is 500, 74. Notice my hyphen. That's in the thousands position. So I put a comma, and then the last thing is just the number 6. So 50,574,006. Number 5. Use digits to write 250 million. So the first thing I do is 250. Put a comma. Then I say the next part is 5,000. So I need 0 for the 100,000s, 0 for the 10,000s, and 5,000, comma. And the last one is 70, 0 for the hundreds and the number 70. So the key with that one, guys, in my mind, is these 2 zeros here and that 0 there, so that you have 250 million, 5,000, 70. Number 7, arrange these numbers in order from least to greatest. So I start with the smallest negative. So I always like to think negative means opposite. So I take the -7 because I have to think opposite. The opposite is what's the biggest number? 7. So what's the least number? -7. Then I go to the other negative number, which is -1. Then I want the one that is not positive or negative, 0. Then I go to thinking like normal. 4 is next, 5 is second to last, and +7 is the biggest number we got. So you have your orders from least to greatest. Number 9. The rule of a certain sequence is k equals 3n. Find the first 4 terms of the sequence. So I have k equals 3n, and I'm just sticking in the first 4 numbers. So a letter next to a number means multiply. So 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, 4 times 3 is 12. Maybe you didn't need to write the stuff out on the top that I did. You can just say, hey, I can multiply or I can count by 3s, but we're working and we're practicing those things. Number 10, says 2 times 3 times 5 times n equals 960. I'm missing something in multiplication I divide, but they just made that a little bit more difficult for me by making me multiply first. So they gave me 2 times 3 times 5. I don't think this one matters. Some of you might want to do 2 times 3 is 10. I'm sorry, 2 times 5 is 10 times 3 is 30. Maybe you just went right in order. 2 times 3 times 5 is 30. Anyway, you look at it, you got 30. Now I got to take that 30 and I got to divide it into 960. So 30 into 90 goes 3 times. I subtract, bring down that 6, bring down that 0. 30 goes into 60 twice. My answer is 32. Number 12, missing something in addition, I subtract. But before I can subtract, I have to add the two numbers they gave me together. So I have 17 plus 5 equals 22. I then take 22 and subtract it from my 50. Cross out, borrow, 10 minus 2 is 8, 4 minus 2 is 2, and I get an answer of 28. Number 15, I'm missing the divisor on the bottom, so it stays a division problem. 144 is going to be divided by that 8. 8 goes into 14 once, multiply 8, subtract 6, bring down 4, 8 into 64, 8 times. That's 64, which gives me a 0. Backside of your answer key, number 16. 16 says write this in expanded form. I have 7. It's in the hundred thousands position, so you might have just went this way. Or you might have said how many zeros or how many digits are after that 7. 5, 0, 0, 0, 0. I counted 5, so my number has 5 zeros in it. I have 7 times 100,000 plus, next number is 5. And it's just right next to it, guys, so I just go, hey, there's 1 less 0. Boom, put it in parentheses. The rest of them are all zeros, so I'm done. Down to 22, I have parentheses first, 144 divided by 12. Some of you might know this as the perfect square. So 12 times 12 is 144, so I did the division, I got 12. Now I take that answer and I divide it by the number they gave me, which was 3, and that goes in there 4 times. So my final answer is 4. 25 has parentheses, which means I need to do it first. Notice they have dollars and cents, so I'm got to make them the same. So I have $4.60. I'm minusing 39 cents from it, written like a dollar though, so that I can do the correct subtraction. Becomes a 5, 10. 10 minus 9 is 1. 5 minus 3 is 2. Decimal straight down. 4 minus nothing is 4. I have $4.21. Step 2, take my answer and subtract it from $10. Sorry for the sloppiness. I'm still learning how to write with these fancy things here. Okay, 10 minus 1 is 9. 9 minus 2 is 7. Decimal straight down, 9 minus 4 is 5. And I have $5.79. Number 27 says, which property can be used to find the unknown number? 365 times what gives me 365? That's times 1. We call 1 the identity property. 52 times 7 equals 7 times what? Well, I have 52 times 7 on the left. I have 7 times 52 on the right. I changed the order. When you change the order, you have the cumulative. Cumulative property of multiplication. 28. Use words to describe the rule of the following sequence, then find the next 3 terms. 10, 8, 6, 4, 2. The rule in words is subtract 2. Okay, now I got to find the next 3 terms, so I keep subtracting 2. 2 minus 2 is 0. 0 minus 2 is into the negatives, guys. Negative 2. And the last one would be negative 4. 29 says, classify the name of the numbers illustrated. 1, 2, 3, 4. That sounds like we're counting. If you had a different answer, you would be allowed to write natural numbers to keep that straight. The counting or natural are the same thing. B, we added the 0 in front of it. Those are whole numbers. C, we added the negatives in front of it. Those are the integers. So great review of our 3 types of numbers. We're going to get a few more as the year goes on. But it starts at 1, it's counting. Adds a 0, it's whole. Adds negative, it becomes integers. And last, 30. Use braces, ellipses, and digits to illustrate a set of negative even numbers. Okay, so my first negative even number is -2. Now guys, negative goes to the left. So the next thing I need to do is write -4 to the left of it. After that, I need to do -6. Now you need to have at least 3 numbers so we can figure out the pattern. Then that pattern continues forever. So an ellipsis is these 3 dots, and then they want braces. So I just write a little squiggly line. You might make it look like kind of parentheses, but it really doesn't matter. But the biggest thing here, guys, is that you write negative numbers going that direction. So you didn't want to do -2, -4, -6. That's not how our number line works. So that one, bad. This one, good. Ellipse on the left because it goes that direction. Have a great day.